Okay, so we're going to talk about, so before we were, the previous video, we kind of talked about how we can put it together these um, um, molecules by figuring out how many pairs of electrons they need to share, right? Um, but as you get to more complex formulas, it's kind of a pain to figure out what's sharing. It kind of takes up um, a lot more time. So this is kind of a way to accurately and quickly figure out what the structural formula is for particular molecules. So the first is you add up all the valence electrons. I'm just reading through this. You place the least electronegative element in the center. Usually it's the first atom. So usually the first atom is what we call the central atom. Then you draw a bond between all the central atom and all the terminal atoms, the atoms on the outside. Then you subtract bonding electrons from the total valence electrons because you use them up, if that makes sense. And then you place leftover on the terminal atoms. Any more leftovers that you have, you put on the central atom. So let's do examples because I think that's the best way to go through this. So phosphorus trichloride is PCl3, right? Tri. Okay, so what we're going to do is we're going to try to figure out how to do this, right? Like how to draw this molecule out. So the first thing we have to do is we have to add up the valence electrons. So phosphorus is in group 15, it has 5 valence electrons. Chlorine is in group 17, it has 7 valence electrons. And there's 3 chlorines, so a total of 21. So if we add this all up together, so you're going to add all the valence electrons. The valence electrons are the ones that are going to participate in bonding. So we're going to add them up and then distribute them so that we can kind of figure out where everything goes. So 21 plus 5 is 26. So we have 26 valence electrons to kind of play with to figure out what this is. The second step is we're going to put, now this is not the most electronegative, so usually it's the first. Usually the first one is the central atom. So if you're kind of unsure, I just usually use the first one. And then chlorine will be around it, right? And we know that they're bonded together because they are together in a chemical formula. So we're going to put, now, each bond that we put in there, right, is worth how many valence electrons? Remember, each bond is 2 shared pairs, right? So we used up out of what so we have 3 bonds. Each of them have 2 electrons each. So we used up 6. So I used up 6 electrons, so now I'm down to 20. Now what I'm going to do is I'm going to add electrons to my terminal atom. So this is called my central atom, and then my terminal are the ones on the outside. So we're going to fill up the electrons on the outside. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Now, basically I complete the octet for my terminal atoms. How does this work? Well, there's 2 here, right? So 2, 4, 6, 8. By putting there, I actually added more dots in the night. But by adding 6 more to each chlorine, I've completed the octet. So those chlorines are happy, right? The goal is to make everybody happy. So 6 times 3 is 18. So I only got 2 more. Well, we always place the leftovers here. So if you look at it, phosphorus actually has 8. It has 3 bonds, which is 6 electrons, plus 2 more gives me 8. I used up the 2, I'm down to 0. Perfect. Everybody has an octet. This is what phosphorus trichloride looks like. Let's check out carbon dioxide. So carbon dioxide, CO2, right? So let's first figure out the valence electrons. So carbon has 4, and then oxygen has 6. It's in group 16 times 2, since there's 2 oxygens, so you get 16 electrons, right? 6 times 2 is 12 plus 4 is 16 valence electrons. Carbon goes in the middle. It's bonded to oxygen. How many did I use? Oh, well, I used up 4. I had 2 bonds, 4, so I got 12. So let's fill up those oxygens. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, right? All right, so how many did I use up? 2, 4, 6, 8, 10, 12. Cool. Now, here's what we got to do, though. We got to check if the octet rule is being followed, right? And so if we look here, it's actually not being followed because carbon only has 4 valence electrons and it needs to have 8. So what about instead of taking these electrons, I just put the double bond here and then take this here and put it here. Okay. So what does that do? What does that allow me to do? Well, does everybody have 8? Oxygen has 2, 4, 6, 8. 2, 4, 6, 8. And then carbon has 2, 4, 6, 8. And what I did is instead of giving the pairs of oxygens only to, a pair of electrons only to oxygen, I had them share it with that carbon, which actually allowed the carbon to complete its octet. Let's take a look at nitrogen. So nitrogen is N2. So nitrogen is let's see, nitrogen has 5, so has 5 valence electrons times 2 gives me 10 valence electrons to play with. Now there's no central atom, right, in this one, so it's N with N. So there's different ways to think about this, but they have to be bonded to each other, right? So that's okay. Now I got 8 to play with, but the problem is I need 8 around each nitrogen. So like if I do this 1, 2, 3, 4, 5, 6, that's cool. I have 2 left and I put it on here. Well, that's not good, right? Because while the right side nitrogen has 8, the left side has only 4, right? 2 from the bond and 2 that are lone pairs. But what I could do is I could do that and then share those electrons. So now I have the right side's still cool, 2, 4, 6, 8. It's still not good on the left side. I can only just take another one and make a bond. So there's a triple bond here going on. And then just to remind you here, there is a sigma bond, 1 sigma, and 2 pi bonds. Remember, the first bond is a sigma, the second bonds, or the bonds subsequent, are called pi bonds, right? Hydrogen peroxide. Ooh, this is interesting. So we got, and these are always kind of difficult. Now, hydrogen only needs 2 electrons, so it's not going to be our central atom. But before we do that, hydrogen has 1 valence electron times 2. Oxygen has 6. So that'll give us 12. So this is going to be 14. Right, 12 plus 2. Now, oxygen is the more... There's 2 reasons why hydrogen can't be in the middle. One is hydrogen can only bond once. It only needs 2 valence electrons to be full. So it wouldn't be in the middle, the center of everything. Hydrogens are usually on the outside. So if I had to guess, it would look something like this, where we have 2 oxygens bonded, and then each one like this. So if I bonded them all together, it'd be 2, 4, 6. So that only give me 8 valence electrons to work with here. Around this hydrogen, I got 2, which is what I need. This hydrogen, I got 2. The oxygen only has 4, so let's add 2 more here. So that gives us 8. So I used up 4. And then the other oxygen. Oh, sorry, this is 4, right? And then subtracting over 4 is 0. So that's what hydrogen peroxide. Everything is good in the octet rule. Okay. Ooh, this is an interesting one. So CH2O. Let's do so what is C? So C is what, 4? Hydrogen is 2. Well, sorry, 1 times 2, right? And then oxygen is 6. So you should get 12. All right. Carbon is listed first, so it's going to be the central atom. And then these three are going to be bonded. So you're going to have a hydrogen, and an oxygen, something like this. I mean, it doesn't have to look exactly like this. So this is 2, 4, 6. So I have 6 left. If I put them on carbon, 1, 2, 3, 4, 5, 6. All right. So oxygen's cool because it's got 8, but carbon only has 6. So actually what I need to do is when one is 1 short, we take a pair from a terminal and create a double bond. So it's kind of fluid, if that makes sense. It's kind of fluid where these electrons can go. We're just trying to figure out where to position them in the best place. And so we always use this method to kind of figure it out. So hopefully that makes sense. It's not like we're taking oxygen's electrons. Here are the electrons we kind of have to play with, and then how can we set it up so that everybody fulfills an octet rule, or everybody is full. All right, one more. Let's do C3H8. So this is our central atom, but let's do our valence electron. Sorry, jumped the gun here. So 6 times 3 is 18. There's 8 hydrogens. Each hydrogen has 1. Oxygen has 6. So 6 times 3 is 18, plus another 8, 24, right? 24 electrons we get to play with. Carbon's actually going to go in the middle, which is our central atom, and they're all bonded to each other. And then we got 8 hydrogens. So let's see how we can do this. So we can put a hydrogen on here. That's 1, 2, 3, 4, 5, 6, 7, 8. That's it. Those were our 8. And what I did is I just put I know carbon can fit 4, right? At least these and carbon. So 1, 2, 3, 4. So I just put hydrogens where they would fit. And let's count it up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 would be, we used up 20 electrons. Oh, I made a mistake. We should be 20, but I'm sorry. I know what I did. Carbon's not a 6. Carbon's a 4. I was looking back. So this should be 20. My fault. So carbon, sorry, has 4 valence electrons. So this would be 0. This is what this would look like. Okay.